This is Unit 2, Segment Lines and Angles, Lesson 2.6. We're graphing with parallel and perpendicular lines. So you are taking a look here. And these are the things we're going to talk about: slope, parallel, perpendicular, opposite, inverse, and rise over run. So you want to watch out. Parallel and perpendicular lines come into play in a lot of areas. Here we have the Blue Angels flying in a parallel formation. And here, these two airplanes crossed at nearly, in 3D version, they nearly crossed at a right angle because they're flying horizontally. So parallel and right angle. So definition of parallel, let's trace this. Parallel lines would be like this. They're the same direction, but never intersecting. Those are parallel. Same direction, never intersecting. Same direction, never intersecting. Perpendicular, they intersect specifically, so this line right here and this line here, they do intersect, but they specifically intersect at a right angle. So this word perpendicular, the symbol for perpendicular is like an inverted T. So this is the symbol for perpendicular because things meet at a right angle. Warning, the next two concepts are always, without exception, I've thrown down this challenge for when you take the PSAT in October. Make sure you watch out. You are always going to have at least one question that deals with this: slope and parallel lines, and slope and perpendicular lines. In over a decade, I've asked students to watch out for this, both on the PSAT and the SAT. And without fail, every single time, these concepts have come up on the SAT test and the PSAT, so watch for it. I'm going to give you an example. We're going to talk about slope and parallel lines first. Let's shrink this out just a bit. Okay, we are going to plot the points, -6, 6, right there, -6 over 6, up 6, plot a point, always write the coordinate, -6, comma 6, and 0, 4, so 0, up 4, right there, 0, 4, and we're going to draw a line X between these points. And now it says we want to find the slope graphically by bunny hopping. So we're going to get kind of close here. And let's find this slope graphically. So bunny hop. 1, 2. 1, 2, 3, 4, 5, 6. So that's 2 and 6. My rise is 2. My run is 6. And then if you look very carefully, it's a negative line. So the actual slope of this blue line, we're going to reduce that. 2 over 6 is -1 over 3. So we're going to plot our points -1, 0, and 2, -1. So -1, 0 is right here, and +2, -1. We plot this line. And we're going to find the slope using the slope equation this time. Remember, which is y minus y over x minus x. So we make a template. Ready? We're going to put our y's on top, so 0 minus negative 1. And our x's down below, negative 1 minus 2. This double negative becomes positive 1 over negative 3. Again, the slope is negative 1/3. Now look what you have here. Slope equals negative 1/3. I want you to observe two things. Trace these lines with your pencil. Just physically trace them. It'll help register in the brain. Trace them. Notice the lines are parallel. Put the little arrow feathers. That means parallel. If the lines are parallel, the slopes are equal. If the lines are parallel, the slopes are equal. So we just figured out when you have parallel lines, slope is going to equal to slope. Parallel lines have the same tilt. That's pretty common sense. Keep that in mind. Say it out loud. When lines are parallel, slope equals slope. Say it again. When lines are parallel, slope equals slope. When lines are parallel, slope equals slope. Now we're going to go through a similar process. Let's plot negative 3, positive 2. And 3, 0. Draw on your line. And again, we're going to find the slope graphically here. Graphically, which means we're just going to bunny hop it. Bunny hop it with me, please. Ready? 1, 2. 1, 2, 3, 4, 5, 6. So that's 2 over 6, which reduces 1 over 3, but again, we have a negative line. Goes down from left to right. So our slope for this first line, the slope is negative 1 over 3. Now we're going to plot the point 6, 6 and 5, 3. Oh, you're supposed to name these lines. That was J, line J. So 6, 6. And 5, 3. And draw your line. And this is supposed to be line K. We're going to find the slope by doing it algebraically. Rise over run. So rise, we subtract the y. So 6 minus 3. Run, we subtract the x's. 6 minus 5. Let's reduce that. That's going to be 3 over 1. So the slope of K is 3 over 1. Now look really carefully. I'm going to pause here just for like 30 seconds. These lines obviously are not parallel. Physically trace them. They're not parallel. They are, however, perpendicular. Look really carefully at these slopes. Look what we have. We have 3 over 1, and we have negative 1 over 3. Take a second and see if you can't verbalize how are these slopes related. Just stop, say it out loud to yourself. If you look really closely, negative 3 over 1, and then you have negative 1 over 3 and 3 over 1. You can call them the opposite reciprocals. Mathematically, how are they related? If you times them, this ends up being negative 3 over 3, which is negative 1, which is the property of all perpendicular slope lines, is if lines are perpendicular, the slopes multiply to negative 1. When lines are perpendicular, slope, perpendicular, use that little upside down symbol. Slope times slope equals negative 1. Again, for example, we had negative 1 over 3 times 3 over 1, that equals negative 1. So if you see these slopes, you know they're perpendicular. So when lines are parallel, I'd like you to summarize yourself. I want you in your own words. I'm not going to write that in for you. I expect to see you write something in there yourself. Summarize. When lines are parallel, what do you notice about the slope? And when lines are perpendicular, what do you notice about the slope? I'm not going to fill that out for you. I want you to come up with something on your own. So let's do a couple examples. It says, find the slope of a line parallel to the given line and a line perpendicular to the given line. So this is our given line. First step, let's go ahead and find the slope of our given line. I'm going to do it graphically. So let's find the slope of our given line. We're going to do rise over run. So our rise, 1, 2, 3, 4, and our run, 1, 2, and look at the overall line. It's a positive line. Let's reduce this, so it's going to be positive 2 over 1 is our given line. So if a slope is parallel, we know slope equals slope. So a parallel line must also have 2 over 1. Let's actually try that real quick and see if it works. So let's randomly choose any point. And let's count out a 2 over 1 slope. Okay, we're going to rise 2, go over 1, positive. And if you go like this, you see that you have a parallel line. Rise 2 over 1. This should read what would be the slope of a perpendicular line, since we already did parallel. In that case, slope times slope equals negative 1. So to find that slope, we're going to go 2 over 1 times something equals negative 1. And you ask yourself, what is that something that goes here? It's going to be the opposite reciprocal, so it's going to be negative 1 over 2. So to see if you're right, let's graph that. So let's choose any 2 points here. I'm going to put a dot here. And I'm going to rise 1. And I'm going to go over 2. I want it to be negative, so I'm going to go left. Ready? Draw a line. Lo and behold, we have a perpendicular line. So here's a very common algebra problem that is very common on SATs. It says find the slope of a line parallel to the given line, then perpendicular. Let's write down our properties. For parallel slopes, we know slope equals slope. For perpendicular slope, we know slope times slope equals -1. For us to identify the slope, you guys are used to writing it in y equals mx plus b, where that m is the slope. Problem is, right here, we don't have y by itself. So first off, we have to isolate the y. So let's do that. Remember, y has an attitude, so who leaves first? Not the date, the other couple. So we're going to minus 3x, minus 3x. We have y plus its date, and then we have -3x plus 20 on the other side. Remember, the goal is to get rid of y all by himself. So now we're going to get rid of the date by dividing by 5. And remember, when the date gets ditched by her boyfriend here, she's going to go over to the other side and gossip to every single person. So make sure you take that 5 to every term. We end up with y equals -3/5x plus 4. Let's write this right under here. Y equals -3/5x plus 4. Now we see the slope of the line is -3/5. So a parallel slope would be -3/5. To find the perpendicular slope, it's -3/5 times something equals -1. And you ask yourself, what goes in that something? I want you to take 10 seconds and fill that out yourself. Okay, you should have written positive 5/3. So our perpendicular slope is the opposite reciprocal, which is 5/3. Very, very common question on SATs and PSATs. Here's another common question. It says, write an equation of a line with the given information. Then graph both the original line and the derived, that should say derived line. Okay, so we have what's called our given line here. This is our given line. And we want another line that goes through this XY point and is perpendicular. We're going to do this one over here by hand because I think it's easier to see what's going on. So our given line is right here. Given line. And we want our derived line to have two qualities. It's going to have this point in it. It's going to go through this point, 5, -4, and it's going to be perpendicular. We're going to do this both algebraically and graphically. So our given line, first we want to write y equals mx plus b and ask ourselves what we can find. Y equals mx plus b, right underneath. Highlight the m, which is your slope. Highlight what's right above it. So our given line slope, we're just going to write given line. The given line slope has to be 5/7. Now the derived line, we want it to be perpendicular. So we write out our perpendicular property where it's slope times slope equals -1. So it's going to be 5/7 times something equals -1. 5/7 times something equals -1. Ask yourself what that something is. Something should be the opposite reciprocal, which is -5/7. So for our derived line, let's write our equation. We want y equals mx plus b. So we know for our derived line, our slope is going to be, that's going to be flipped, -7/5. It's going to be -7/5. That's our derived line because we want it to be perpendicular. Problem is we don't have our b, but look what we do have. We do have an x and a y, so we're going to take this slope, put it in right there, -7/5. B we don't know. Ready? Circle, plug, chug with me. We do know our x, which is 5, and we do know our y, which is -4. So we're going to solve for b here. I'm going to bring in the algebra a little bit closer. Ready? 5 goes into 5 one time. So I have -4 equals -7 plus b. Want b by itself, so I'm going to add 7 both sides. B is going to equal -4 plus 7 is +3. So that's our b for our derived line. Now we have our two equations here. We have our given equation, y equals 5/7x plus 2. And now we have sufficient information for our derived, which is y equals mx plus b. It's going to be y equals, the m here is -7/5x plus +3. We're going to graph these two lines. We're going to use green for the given, pink for the derived. So here we're going to start at +2 on the y-axis. And it's 5/7 positive. I'm going to go up 5. 1, 2, 3, 4, 5/7. 1, 2, 3, 4, 5, 6, 7. And there is our first line. That's the green line. Now the pink line is perpendicular, so it's going to have this -7/5. It's going to go through that point, 5, -4. So let's plot that point first. So over 5, down 4, 1, 2, 3, 4. And now let's count that negative 7 over 5 slope. So it's going to be negative 7 over 5. So I'm going to go 1, 2, 3, 4, 5, 6, 7. That's our rise is 7. Our run is 5, but we have to go negative, so we're going to go left. 1, 2, 3, 4, 5. Line that up. So we're going through that point, and our slope was negative 7 over 5, which we counted out. And lo and behold, yes, they're perpendicular. More importantly, look where they cross the y-axis. Look at that, positive 3. Ain't that nifty how these work together? So I'd like you to pause and do this page on your own. Do pause the video. Please, please, please pause the video. Do this page on your own. It'll take you a couple minutes. And then restart the video when you are finished checking your work. Okay, if you've been hearing a jingle in the background, that's because my cat's been very interested in what I'm doing here. So I'll let you say hi to Sloopy. This is Sloopy. She's a Siamese. She's a rescue kitty. And this is probably the only time you'd ever see her because she's a very shy cat. If I have guests, she hides under the bed. So you're a privileged few. This is the only time anybody sees her. So if you want to take a shot at extra credit and you actually got to this point and you're actually listening to it and not copying from a neighbor, which you would never dream of doing, in the margin, right here, I'm going to look at this page. I'd like you to write out what was my cat's name. What was my cat's name? And if you could write that in and tell me what she looks like, I will give you +1 extra credit, just as confirmation that you're actually watching the video and not copying. Okay. Let's take a look here at what you did. Check your work. So it says we want to find the slope of a line parallel to the given line and perpendicular. So we're going to start by finding the slope of the given line. So let's bunny hop the rise and the run. So the rise is 1, 2. The run 1, 2, 3, 4, and 5. So it's 2 over 5, and it's a negative line going down. So that is our given slope. Therefore, our parallel slope is going to be exactly the same thing, negative 2 over 5. Our perpendicular slope is the opposite reciprocal, so it's positive 5 over 2. If you want to confirm that, let's try a positive 5 over 2 and see what happens. 1, 2, 3, 4, 5 over 2. Whoops, that's going to be positive, so we have to go to the right. Keep counting the wrong way. 5 over 2 to the right, positive. Let's go ahead and draw that. Lo and behold, they are perpendicular. So that confirms there is your parallel slope, there is your positive slope. It says find the slope of the line parallel to the given line and also perpendicular. This is y equals mx plus 3, b. So our m, our given slope, is 7 over 5, which means your parallel slope is also 7 over 5. Your perpendicular slope, 7 over 5 times something equals negative 1. Ask yourself, what's that something? It's going to be the opposite reciprocal, negative 5 over 7. We're going to find the slope of the line parallel to the given line. The problem is it's not in y equals mx plus b form, so we have to do that first. So there's our y. Our goal is to get y by himself, so we're going to minus 4x. Minus 4x, so we end up with y equals negative 4x plus 5. Underneath, y equals mx plus b. You can see our slope is negative 4, so the parallel slope is negative 4 over 1. Perpendicular slope is going to be positive 1 over 4.